Part A of the question is that why is it necessary to use water that is both distilled at and at room temperature when doing dilutions? It is necessary to use distilled water that is at room temperature when doing dilutions because we don't want unexpected factors like mineral in water like mineral minerals in water or hot or cold temperature to affect the result of an experiment. In other words, distilled water is basically inert, nothing in water but H2 and O2. So distillation kills most organic matter and removes mineral from water, making it ideal for experiments. Making it ideal for experiments. In part B, we have to outline an experiment procedure step by step by which 25 ml of 1 mH HCl can be made from stock solution of 5 HCl. So, start part B. M dilution, volume of dilution equal to M stock, volume stock. So substitute the values we have 1 to 5 equal to 5, and volume of stock we have to find, so we represent it by x. Solve for x and we'll get that x is equal to 5 ml. So x is 5 ml of stock solution. So step 1 is that to make solution of 25 ml of 1 HCl from 5 HCl, we have pure 5 ml of stock. We have we have pure 5 ml of 5 ml of stock solution into 25 ml of volumetric flask. Step 2 is dilute it with solvent. Dilute it with solvent to 5 ml line. Step 3 is that finally we have 25 ml of 105 m HCl solution. So these are steps. So these are steps of an experimental procedure by which we have 25 ml of 101 m HCl can be made from a stock solution of 5 m HCl. In part C, we have to calculate molarity of H3PO4 solution prepared as follow: 5 ml of 10 phosphoric acid is diluted to 250 ml in volumetric flask, and from this flask 25 ml of this solution is diluted to 500 ml in another flask. So in this part, we have to perform two dilutions. So first dilution is V1 is equal to 5 ml, M1 is equal to 10 m, V2 is equal to 250 ml, and M2 we have to find. So 5 into 10 equal to 250 into x. This is M2, presentation of M2. So we have to solve for x, and we find that x is equal to 0.2 m. So molarity of H3, molarity molarity of H3PO4 in first volumetric flask is 0.2 m. Now we have to perform second dilution, where we have V1 is 25 ml, M1 is 0.2 m, V2 is 500 ml, and M2 is equal to X. So 25 into 0.2 equal to 500 equal to X. Solve for X, and we get that X is equal to 0.01 m. So molarity of H3PO4 when above solution transfer to another flask is 0.01 m. So this is molarity of H3PO when it is transferred to another flask.